Hello YouTube, this is Friaza, and today I'll be showing you how to make a dot activated tool on Roblox using Roblox Lua programming language. First of all, you'll want to view Explorer, view properties and view output, like I used in the last tutorial, and then you'll want to open your players and then go to your name and click on your backpack. With your backpack highlighted, go to Insert, Object, and then insert Tool. It should be an orange spanner, and then click OK. Now that you've got the basic tool inside your backpack, rename the tool to Wall, or whatever you want to call it. It won't matter what you call it. And then for it to be a tool, it will need to have a handle, so insert a part and rename that part handle. It has to be called handle, otherwise the tool will not work. I do not know why. But right now it's just an empty tool. I mean, you can equip it and you'll see the brick, like so, but it won't do anything, so as you'll have guessed, it'll need a script. So click on Wall, or whatever your tool's name is, and insert a script. There we go. And now double click the script to get inside it. We won't be using .touch today. We'll be using another function named .activated, which will activate when the player clicks their mouse while the tool is equipped. So start off by deleting the classic print and write function on activated. Of course, as I said in my last video, you don't need to call it function on activated. You can call it function bananas, as long as you remember later when you're writing the connection line that you're connecting it to bananas and not on activated. And then we'll put the usual function brackets here. We won't be naming what we activate part as we did with the .touch script last time. The brackets will be empty this time. And then ends, as the blue line signifies that the function requires an end. And so we don't forget later, script .parent .activated connect and the function name, which is on activated. You might be wondering why I wrote script.parent.activated instead of script.parent.touched. Well, that's because we're activating the tool by clicking it this time, not by touching the part. And of course you can't touch a tool, you can only touch a part. So now that that's out of the way, we'll write script.disable equals true and the wait delay, and script.disable equals false. And now we've got our basic clicking tool. I didn't mention strings in the last video. A string is a variable which doesn't hold a boolean value like true or false, or a number value like 1 or 50 or anything. Instead it holds letters or a series of letters. For example, if we write here print, when you're printing a variable you do not put these wee pink quotation marks, but if you're printing something that isn't a variable, you have to put these in, because otherwise it will think you're printing nil. So yeah, first of all write print brackets quotation mark hello output, or whatever you want to say to your output, and Then when you click the tool, it should say in the output your message, and if it does, that means that it works, and that is how you use strings. Now moving on, it'll be handy later to let's tag our player's name, because our player is important for things that you'll be doing with the tool. So when you equip the tool, it will go inside your character, like a hat or a shirt. So let's imagine that the tool is among these items. The script parent is the tool, and the script's parent's parent is your character. So we'll print the script.parent.parent and see what that does. Of course, no quotation marks since it's not a string. And it should say your player's name now. That means it works. Of course, we didn't put this before the function because you might not have the tool activated then, and instead it will print your backpack, which we do not want. But when you equip the tool, it goes from your backpack to your character and will then work. So let's write in player equals game.players get player from character script.parent.parent, and then we'll print player, and then we'll wait a second and print player.character. You'll be wondering what this does. Well, first of all, GetPlayerFromCharacter is an inbuilt function which it tries to get a player name from the character name. A character is your player's character, which is inside workspace, and your player is inside its own folder in players. So it tries to get your player in the players folder from your character in the workspace folder. Hopefully you'll understand that. It's a little confusing at first, but and as you'll see, it prints my name twice here, Friaza. That's because your player and your character have the same name. Your player doesn't have a physical body, but it's used to hold details like your camera mode, your character appearance, your user ID, and your team colour. But your character is your physical body, which has your things like hats, shirts, pants, limbs, if you get what I'm saying. We don't actually need to print these, so once that's working we can get rid of that. Now what I want to do in this tool is create something like an earth wall, or a barrier almost. Most of my tools in my second Naruto game were based on dot activated tools. So if you're interested in making like battle or fighting games like some of you are, such as Air Gear, this will be pretty handy. First you'll want to create a part using I'll write it first. Instances, well, what that does is it searches the insert objects folder and inserts whatever you put inside your quotation marks. You'll better understand it if I show you here. If I go to insert objects, these are all the instances you have in the game. Ones that I commonly use are body velocity, fire, explosion, smoke and sparkles, as well as special mesh. you can insert all of these using instance, Instance.new, bracket, quotation mark, instance name, quotation mark, closing bracket. What we're doing in this script is we're inserting part. We've done this many times in this tutorial and last tutorial, but this time we're doing it via script. Of course you can't, insert objects, parts in play mode while you're scripting with your scripting tool, so you doing it with script is a lot more handy. So we'll, if it doesn't have a parent, then it won't exist. So we'll make the balls parent our workspace. You don't actually need to put game before workspace, that's just a habit of mine. So wall.parent equals workspace. There we go. And right now it should appear in the centre of the map as a normal brick. Add a delay and wall remove. Now this should create a grey brick in the centre of our map, and it will wait 5 seconds and then remove the brick. Oh, well, as you can see, it appeared for a second and then went through the map. Let's try anchoring the wall. And as you can see, it kind of jams itself halfway inside our map. At least we know it works, but it's virtually useless, so let's get rid of that anchored. No, we'll keep the anchored actually. I haven't mentioned this before, but there's you can manipulate positions via script. Like as you walk around, all of your character's body parts constantly change position. Like right now, my character's torso position is -3.708 on the x-axis, 3.292 on the y-axis, which is up and down the ways, and 15.2 on the z-axis, which is, well, it depends on which direction you face, but the one really stays the same as the y-axis. So let's try changing the position of the wall. Wall.position. One of the data features of every parts in workspace is position. So that's quite easy to find. It's in the data category, along with rot velocity, name, and velocity. Of course, the ones we use the most are going to be position and name here. So we'll change the position to vector 3.new 555. Vector 3 means, well, it refers to the 3 axes of x, y, and z. X is usually left and right, y is usually up and down, and z is usually what makes a game 3D, which is forward and backwards. If a game only has x and y axis, then it's considered 2D. So yeah, this will change the position to 555. Of course I don't know what that is right now. And 000 probably refers to the centre of the map, so what that does is it finds the centre of the map by default and moves the brick along 5 spaces in every direction. But this is useless, so we'll get rid of this. What's better than position is CFrame, but the difference between position and CFrame is the position tries to move it to the location, and if another object is in the way, it will teleport your object above that object to avoid problems. But CFrame is more useful but also buggier, because it will try and move it to the position that you want by forcing it there, and if another object is in the way, it will jam your object into that other object. If your part is unanchored, this could cause problems. like suddenly popping out of the block and hitting your character and causing you to fly off the map, possibly breaking your camera. But we'll change the CFrame to player.character.torso. Okay, now what this does is, as I mentioned before, your character is inside your player. Your player is inside the player folder under your name, which we've already tagged as player equals game.players GetPlayerFromCharacter script.parent.parent. Your character, you won't actually see it inside here. You can see backpack, starter gear and player GUI, but you'll wonder why character isn't here. It's because character can only be in workspace, so it automatically links your player to your character. But one of the data features in player is character, so it will tell you your character is Friaza, or your character's name, so it links them together. And what this line here does is it changes your it changes the wall CFrame to your character's torso CFrame, so it puts that block inside your character's torso, but it doesn't do that because it times that CFrame by CFrame.new 005. As I mentioned before, the first number in these three are left and right, which is the x-axis, up and down, which is the y-axis, and forward and backwards, which is the z-axis. And what we're changing is the z-axis. If this was 5, then it would move behind our character, but since it's -5, it moves in front of our character. I don't know why it's reversed, but it just is for some reason. So it's -5, and this will be a few studs in front of our character. But first of all, we'll want to resize the wall using wall.size. Let's use base to show you. Size is also a feature inside part. Of course, this isn't named part; it's called base, but parts, this section of that's here. So we can change the size here. The size of our base plate is 512 0.4512, which is pretty big, but of course our wall will not be anywhere near that big, so wall size equals, this uses vector3.new as well, vector3.new, and we'll give it the size of, let's see, we'll want the height to be 20, and the width to be 15 there. So its width will be 15, its height will be 20, and its breadth will be 3. Since it's only 5 studs in front of us, we won't want it to be too thick, otherwise our character will be jammed inside it and possibly fall over, as used to happen in my Naruto game often. But the wall will be a little plain, so let's make it more interesting using brick colour. So brick colour is inside the appearance section of a part. As you can see, the brick colour of our base is dark green, or whatever your base's colour is. So let's find a nice wee colour for our wall. It's already grey, so we'll make it brown. Wall.brick colour equals brick colour dot new brown. It's case sensitive, so you have to be careful where the capitals are. Of course, it's pretty random because, as you can see, pastel blue has 2 parts, and both of them have capital letters. Yet medium blue has 2 parts, and only the first part is capital. So this can be quite annoying and break a lot of your scripts. So be very careful about how you write the colour's name. So what this line will do is it will change the wall's brick colour to a new brick colour, which is brown. Now let's try this out. And yes, it works. It places a new brick in front of us by 5 spaces for 5 seconds, like an airfall in Naruto almost. Hopefully it will work for all of you as well. But let's make this a bit more interesting now. As the wall is very plain, we can change all the features inside a brick. Transparency, reflection, material, brick colour. So let's change the material. Wall.material equals. This is a good example to show you how to use string other than printing in the output. Wall.material equals quotation marks, and then look for a nice wee material in here. I'm going to use grass, since grass seems to cover everything in Roblox. Grass, and this will change the material of our wall to grass, which is more like earth, but it works for both. And as you can see, it looks much better. But as with our script in the last tutorial, it's very plain. So instead of having it as 1523 straight off, we'll copy this line over and make it 4, 5, 1, and then we'll create a loop for Camelot equals 1 into weight 0.05, which is 1/20th of a second, and wall.size equals wall.size plus vector3.new 1, 1, 1. So 5 and since the breadth is only 3 studs thick to begin with, we'll put this in to begin with. And this will bring the size of the wall up to what we want. And after 5 seconds we'll copy this loop and we'll change it to minus so it would reverse the change. But this is awful fast. I'm going to change this to 0.1. This means that it will grow for a second, wait 5 seconds, and then it will get smaller for a second before vanishing. And let's test this. As you can see, it kind of teleports below the base plate and then above the base plate when it goes back down. This is another thing I wanted to show you. When you change the size, it uses position to replace your brick. So if you C-framed it into a location, then this will teleport it above wherever you C-framed it in the first place. So what we'll want to do is repeatedly C-frame it to our position. We'll just copy this line, our wall.cframe line, and we'll put it in the grow loop. And we'll change wall.anchor equals false for the shrink loop. And let's see what it does now. as you can see, the wall spawns grey. That's because we changed the colour after we made the brick grow. So I'm going to put this over here, and let's test this again. And the wall grows perfectly and shrinks perfectly. Able to knock the wall over, like realistic physics. One thing you'll notice is when I equip the tool, I have this annoying grey block in front of me constantly. What you can do is unequip the tool and resize this. 444 is a good shape. And I've made it a ball. Pastel light blue. Maybe insert some fire. Insert sphere mesh. Of course you don't actually need to do this, I'm just and you can manipulate things inside the tool like this to create physical attacks as well, like airfalls and Rasengan. So, and you can also change the grip position of the tool in the X, Y and Z coordinates here. And now I have Odama Rasengan. I'm going to make this invisible to begin with, and I'm going to make the scale of the mesh 0, 0, 0, and I'm going to make the fires enabled equal false. And before it creates the wall, I'm going to create another loop here. Meshes don't use size, they use scale, as you can see here. If you can't remember the name of a feature inside something like a mesh or fire or a brick, just scroll through until you find the features like vertex colour instead of brick colour and scale instead of size, to avoid making errors. I'm going to increase the actually I'm going to change before the script even starts, tool equals script.parent, because I'm tired of writing script.parent. Vector 3.new 0.05, 0.05, 0.05. 0.05 is 1/20th of a whole, so if it increases by 0.05 20 times, then 0 will change to 1. And I'm going to reverse this instantly after 3 seconds. And I'm going to enable the fire, so tool.fire.enabled equals true, and after 4 seconds tool.fire.enabled equals false. And after 4 seconds the tool's transparency will equal 1, and before it we'll change it to 0.3. 0.3 and 0.4 are my most common Rasengan colours, since I like to reserve 0.5 for water and 0.7 for fire and such. So that should work. Well, let's test it. Fire is not a valid member of tool. Our first error in the series. Oh, whoops, it's tool.handle, sorry. And tool.handle.transparency. Everyone makes mistakes. It's because I was initially going to make tool equals script.parent.handle and changed my mind, but it somehow remembered as that. And as you can see, it grows like a Rasengan and then 4 seconds later shrinks. Whoops. And then it creates our wall. Secondary colour, I was wondering whether the Rasengan was a little red, so there you have it. This is how you create basic summoning and melee attacks using script. Of course, not too perfectly. But let's say we want the Rasengan to damage. First of all, let's get rid of the wall since we're done with that. We'll put a script in the handle, since the handle is the only part of the tool which will actually hit anything. And inside the handle script, we'll create an untouched script. You can't do -1 in ROBLOX Lua. I'm thinking of Dreammaker and C#, XNA. Okay. Part.parent.humanoid.health equals part.parent.humanoid.health -1, which is quite weak for Rasengan, so I'm just going to change this to 40 and put in our little loop. Wait time so that it doesn't always, well, it doesn't run instantly in 40 frames. So what this does is, well, first of all, we'll add indentations because this is getting quite confusing. What this does is it touches a brick and names a brick part, it disables the script, and then it checks if the part's parent has a humanoid inside it, and hopefully the part's parent will be our character. Actually, I'm going to put script.disabled in here so that it doesn't disable at the wrong place. And if assuming it hits Friaza, then Friaza has a humanoid inside, and it looks at part.parent.humanoid.health, which is 100 right now, and then it will equal itself minus 1, so that means it will keep finding what our health is and minusing it by 1 40 times, which will lower the health to 60. And then afterwards, for a little bit of effect, we'll make part.parent.humanoid.set equals true. This changes the control part of humanoid, set value to true. If it's false, that means that there's nothing in here, it's just a very empty box. That means that you're standing, but once it's clicked, it means you're sitting. Also, if you look at your humanoid while you press spacebar to jump, you notice that jump keeps getting filled with a wee green square box. It only happens for a split second as you jump, not until you land. This will be disabled at first because we're going to activating it using our activate script. So let's disable this here, and we'll name the script Rasengan. Okay, and after our Rasengan has grown fully, we'll tool script.parent, so tool.handle.rasengan.disabled equals false, and this will allow our Rasengan to hit. And then we'll disable it again afterwards. There we go. Now let's test this bad boy out. But I need something with a humanoid to hit, so I'm going to go into my models and look for my classic Anbu dummy test all. Actually, that heals instantly, so I'm going to use my guest instead. The Anbu can watch. Set an example. And as you can see, he loses health gradually and then falls over. I'm going to quickly make this more interesting. Hopefully you'll be able to pause the video and see what I'm writing, and well, I'll get to that afterwards. Actually, I'm going to make the parts parent, X parent the character of the player we hit, because if it is a humanoid it must be a player or an NPC, and we'll make the mesh go inside X. What this will do is it will create a part and put that part inside the opponent, and then it will put a mesh inside the part using Instance.new, you'll find a mesh named SpecialMesh, and mesh type is one of the features inside SpecialMesh, and one of the things you can change it to are sphere. For example, your character's head is a special mesh, so go to your workspace, your character name, head, and then mesh. This is a special mesh, as you can see in the class name, and the mesh type is head, but in the script we're changing it to sphere. But this is a string variable, so you'll need quotation marks around it. 1 means it's the scale of the brick, so the bigger the brick is, the bigger the scale of 1 will be. But what we're doing is making it 4 times as big as the brick scale, but since the brick's apart, that'll be problematic, because we're wanting it to look like an impact of Rasengan, so we'll change x.shape equals ball. Shape is one of the features in apart, and usually in Roblox it's block, but we're changing it to ball. And for effect, x.size equals vector 3.new 2, 2, 2. What this will do is it will double the size of the scale. And let's see what it does now. Okay. Oh, I made a typing error and named it spear instead of sphere. So let's just delete that part. I'll bet you didn't make that mistake though. Here. And hopefully that was the only error in this script. And as you can see, it makes the ball grow and the player gets damaged. But this doesn't look very good, so what I'm going to do is change the brick colour to a light bluish colour. So let's check our brick colour selection. Pastel light blue seems to be going well for us, so let's change it to pastel light blue. And for the durity of the loop, we'll make x.CFrame equals part.parent.torso.CFrame, and we'll change x's transparency to 0.3 or 0.2, no, 0.3. And I'm going to increase the transparency as the loop goes along. There. One thing that's been bugging me is our speed, so let's change our speed by player.character, and let's go to our humanoid. And another feature inside humanoid is walk speed. So the first letter in speed is capital for some reason, even though there's no space. And 60 is a good speed for Rasengan. And then after 5 seconds is up, we'll change it back to 16, which is the default walk speed. In case you don't know what walk speed is, it's for every number on your walk speeds is how many studs on Roblox you can walk every second. Like as you can see here, there's hundreds of studs on my screen, and having 16 walk speed means that the maximum amount of studs I can pass per second is 16. But 60 is much more than that, so it's pretty fast. and let's see if this works. And as you can see, it works better than we expected. A bit too good actually. So what I'm going to do is x.canCollide equals false. This means that while the part teleports to the opponent's torso 40 times, it will not hit them, because that can cause a Roblox friction glitch and send them flying off the map, but luckily it didn't. And it works perfectly. Of course, it doesn't vanish, so straight after it finishes, we'll check if x this is an if statement. What it does is it checks if x, which is our Rasengan impact, is not equal to nil. This means if it exists, then we'll remove x. Yep, so let's test this out. First of all, I'm going to get rid of our wee guest here and remove the part from Ninja, and I will remove his healing script. And as you can see, it works perfectly. But there's one small problem. After Rasengan hits, it doesn't vanish instantly. So to fix this, instead of wait 5, I'm going to put a loop here for 50 do wait 0.1, and what this does is it will wait 5 seconds, or 50 times 0.1, which is 5, and we're going to find a way to check if Rasengan's hit or not. A good way to do this is by our script. What we do is we have enabled it, well, turned disabled to false, and when it hits it turns disabled to true. So we'll, well, first of all we need to move our loop below this, otherwise it won't work. Oh no, wait, never mind. So if tool.handle.Rasengan.disable equals false. This means that it will only wait 0.1 seconds if our Rasengan has not hit. When you're doing if statements of this sort, you need 2 equals. This means is equals to. It's comparing. Normally when you're setting a number like this, walk speed equals 16, you're just changing it. But to compare things, you need to use equals equals, which means is equals to. Try and remember that. Well, let's get our wee ninja up. So that's how you create a Rasengan and an airfall. Hopefully you'll be able to adapt what you've learnt and make other fighting game attacks or dot activated tools, like maybe a remote which opens a door, or something of the sorts. Well, thanks for watching the tutorial, and I'll make more in the near future. Thank you.